This conference will now be recorded.
In the last class, we have studied matrices. We will discuss some important questions in that chapter in the next class. I would like to take the next chapter, determinants, because this is the continuation of matrices. So after completing these two chapters, we will discuss important 2 marks MCQs in these two chapters. If A is a 2 by 2 matrix, A, B, C, D, then how to find the determinant of A? The determinant of A is defined as determinant A, B, C, D. Okay, it is denoted by the symbol DET, the first 3 letters of determinant, DET of A. Okay. Only square matrices have determinants. How to find the determinant of A? AD minus BC. AD minus BC. Okay. So determinant of A is AD minus BC. This also denoted by the symbol, this triangle symbol. We use this symbol. So determinant of A or determinant A, or you can use this triangle symbol. It is here AD minus BC. Determinant of A is AD minus BC. What is the determinant of a matrix of order 1? Let A equal to matrix A. Here we have only one element. In this matrix, we have only one element. It's a matrix of order 1. Okay. It's a matrix of order 1. Therefore, determinant of A is nothing but the element A. Determinant of A is nothing but the element A, because in this matrix we have only one element. Therefore, determinant of A is that element is equal to A. This is what determinant of a matrix of order 1. Okay. Next, determinant of a matrix of order 2. It's definition of determinant of a matrix of order 2. Okay. Here A is a 2 by 2 matrix. A11, A12, A21, A22. It's a matrix of order 2 cross 2. Then what is the determinant of A? It is denoted by the symbol DET of A or determinant A. How to read this? Determinant A or delta. We use this symbol to denote determinant of A. It is given by A11 into A22. You cross multiply these two, A11 into A22, these two elements, then add minus sign, then we multiply A12 and A21. So what is determinant of A? It is A11 into A22 minus A21 into A12. Okay. See some examples. Evaluate determinant 2, 4 minus 1, 2. The 2 by 2 matrix. We can find determinant only for square matrices. It's a square matrix because here the number of rows is equal to the number of columns is 2. Okay, it's a square matrix of order 2. So we will be able to find determinant A. What is determinant A? This problem. How to find determinant A? A11 into A22. We need to multiply these two elements, A11 into A22 minus, then we have to multiply A12 into A21. Okay, A12 into A21. You follow this arrow. So A11 into A22 minus A12 into A21. That is the definition of determinant of a 2 by 2 matrix. So you will be getting 2 into 2, 4, minus sign. Then 4 into minus 1 is minus 4. So minus 4 plus 4, minus 4 into minus becomes plus 4. So you are getting 4 plus 4 equal to 8. Okay. See the next problem. Evaluate determinant. The first row is x, x plus 1, and the second row is x minus 1, x. Here the elements are unknown. Okay, the elements of the given matrix are unknown. This given in terms of x. So that is not a problem. We can find the determinant of the given matrix. Okay, it's a 2 by 2 matrix. So how will you find the determinant A11 into A22? So x into x. Then we have to add minus sign. Then we need to multiply these two. Okay, so x minus 1 into x plus 1. A21 into A12. So when you multiply these two, it is of the form x plus 1 into x minus 1. It is of the form a plus b into a minus b. So what is the formula? A plus b into a minus b. Here x plus 1 into x minus 1 is in the form of a plus b into a minus b. What is the formula? This is a plus b into a minus b is a square minus b square, right? A square minus b square. So here I will get x square minus 1. So on simplification, what we are getting, see, x square, you bring this minus inside the bracket. So minus x square and minus into minus 1 becomes plus 1. So I am getting 1, because here plus x square and minus x square is getting cancelled. So you are getting 1. So what is the value of the given matrix, or what is the determinant value? It is 1. So far we have discussed how to find the determinant of a 2 by 2 matrix. How to find the determinant of a 2 by 2 matrix, and determinant of a matrix of order uh, 1. The determinant of a matrix of order 2. Okay. Now we are going to see the determinant of a matrix of order 3 by 3. How to find the determinant of a matrix of order 3 by 3. Okay. It's a 3 cross 3 matrix. We have 3 rows and 3 columns. Okay. 3 rows and 3 columns. Now we are going to find the determinant of a 3 by 3 matrix. How to find determinant of a 3 by 3 matrix? See the first element A11. Okay. So A11, you cross the row having the element A11 and cross the column having the element A11. Okay. So deleting the row having the element A11 as well as the column. So what is remaining? A22, A23, A32, A33. We can see a 2 by 2 matrix. This is a 2 by 2 matrix. So A11. Now multiply A22 into A33. Determinant of a 2 by 2 matrix. So I will get, open the bracket, A22 into A33. I will multiply these two elements. Then I will add minus. Okay. Next, you multiply these two. A32 into A23. Is that clear? A32 into A23. So this is over. Okay. Now, consider the next element in the first row. What is the next element? It is A12. So what sign will come here? The next element is A12. So you add this 1 and 2. What you are getting? 3. So this is plus 1. And next one is minus 1 whole power 3, because 2 plus 1 is 3. This 2 plus 1 is 3. Okay. Here you will get minus 1 to the power 1 plus 1, because the first element is A11. So here I will get minus 1 power 1 plus 1. It is plus. Okay. So the next element is, since the next element is A12 minus 1 whole to the power 1 plus 2. What is 1 plus 2? It is 3. So what is minus 1 cube? It is minus again. Okay, so consider that element A12. Consider the element, next element A12. Open the bracket. Now delete the row having the element A12 and delete the column, corresponding column also. So what you are getting, see, A21, A23, A31, A33. Again, we see a 2 by 2 matrix of elements A21, A23, A31, A33. So what is the determinant of this 2 by 2 matrix? A21 into A33 minus A23 into A31. Okay, A21, A33 minus A23, A31 plus minus 1 power. What is the next element? A13. Okay, so add these two numbers, you get 1 plus 3 in the power. What is 1 plus 3? It is 4. So minus 1 power 4 plus. Consider the element A13, last element in the first row. So if you delete the row having the element A13 and if you delete the column having the element A13, then you will see a 2 by 2 matrix A21, A22, A31, A32. So you will be getting A21, A32 minus A22 into A31. So this is the value of the determinant. This is the value of the this is the determinant value of the given matrix A. Okay. So A11 into these two elements. We are multiplying these two elements. A22 into A33 minus A23 into A32. Then this is actually plus. Then when you go to the next element, you'll be getting minus. Alternatively, positive and negative. So you will write minus, what is the next element? A12. So minus A12 into, if you delete the row having the element A12 and delete the column having the element A12, then we see a 2 by 2 matrix A21, A23, A31, A33. So find the determinant of this A21 into A33 minus A31 into A23. Then delete the column as well as the row having the element A13. So we will be getting a 2 by 2 matrix. The determinant of this matrix is A21 into A32 minus A31 into A22. So this is the determinant of the given matrix A. A is a 3 by 3 matrix here. Is it clear? So when you consider A11, you have to delete this row and column. When you consider A12, you have to delete this row and column. Okay. When you delete A13, when you consider A13, you have to delete the row as well as the column having the element A13. Okay. So this is the expansion along the first row. Similarly, when you expand along second row, how to consider first A21. So delete the row corresponding, delete the row having the element A21 and the column, corresponding column having the element A21. So you can see A12, A13, A32, A33. Here they have written now minus 1 power. What is 2 plus 1? We are considering A21, so 2 plus 1. A21 into determinant of A22, A23, A32, A33. Next element is A22. So plus minus 1 power A22. So we have to add 2 and 2. Okay. So 2 plus 2. So when you consider this, now to delete the row and the column, right? So the corner elements A11, A13, A31, A33. So A11, determinant A11, A13, A31, A33. Plus, What is the next element? A23. Since the next element is A23, I will add 2 and 3. Okay. So minus 1 par 2 plus 3 into, since I am considering A23, I will write here A23. So A23. So when you consider A23, you will delete this row and this column, right? So you will have A11, A12, A31, A32. So determinant A11, A12, A31, A32. So we need to find the determinant of these three matrices. We need to expand it. So how will you expand? A12 into A33 minus A32 into A13. Similarly, A11 into A33 minus, okay, minus A13 into A31. Here also A11 into A32 minus A31 into A12. So this is the value of the determinant value of the given matrix A, where A is a 3 by 3 matrix, right? So this is expansion along second row. This is expansion along first row. Similarly, we can expand along column wise also. It is also applicable. Let's see some examples. Evaluate the determinant delta equals determinant 1, 2, 4 minus 1, 3, 0, 4, 1, 0. So we need to evaluate the given determinant. Okay. So how to do that? First I am considering 1. So 1 into, multiply these two, then you will get 0, right? 0 minus 0. Then we consider the next element, say A12. A12 means minus 1 par 1 plus 2. So we'll be getting minus here. So minus 2 into minus 1 into 0, minus 4 into 0. Again, you will be getting 0. Plus 4. Why plus 4? Because what is 4? 4 is A31. Sorry, A13. Third element in the first row, A13. A13 means minus 1 par 1 plus 3. What is minus 1 par 1 plus 3? It is minus 1 par 4. What is minus 1 par 4? It is plus. So, plus 4 into minus 1 into 1, minus 1. Minus 4 into 3, minus 2. Okay. So, here I am getting 0. 0 into something is 0. This is also 0. So, here I am getting 4 into minus 13. 4 into minus 13. So what is the value of 4 into minus 13? It is minus 52. It is minus 52. Right? So since these two entries are 0, you don't need to consider. We can consider 4 because these two entries are 0. In the second row, the last entry is 0, and in the third row, the last element is 0. Therefore, we can consider this element alone because 4, if you consider 4, then you will be getting a 2 by 2 matrix of elements minus 1, 3, 4, 1. Here we have non-zero. See the next problem. Evaluate determinant. The first row is 0 sin alpha minus cos alpha. Second row is minus sin alpha 0 sin beta. And third row is cos alpha minus sin beta 0. See the diagonal elements. Here the diagonal elements are 0. The non-diagonal elements are non-zero. Right? The diagonal elements are 0. So how to find the determinant of this matrix? If you consider the first element is 0. So A11 is 0. So 0 into something is 0. So no need to consider this element. You can directly go for the second element because the first element is 0. So when you multiply any matrix with this 0, you'll be getting 0 only. So no need to consider this one. You can directly go for the second element. What is the second element? Sine alpha. A12 is sine alpha. Here A12 is sine alpha. Okay. So I will add plus or minus minus because A12 means minus 1 power 1 plus 2, right? Minus 1 power 1 plus 2 into sine alpha. That is my second element in the first row. Okay, so when I consider this sine alpha, I have to delete the row containing sine alpha as well as I have to delete the column, corresponding column containing sine alpha. So the remaining elements are minus sine alpha, sine beta, cos alpha, 0. I can see a 2 by 2 matrix. So the determinant value of this 2 by 2 matrix is minus sine alpha into 0 is 0. I have to multiply minus sine alpha into 0. Cross multiply. Okay, then minus, I will add minus here, so minus cos alpha, cos alpha sin beta. Okay, minus cos alpha sin beta. Then what is A13? Last element in the first row, it is minus cos alpha. So consider minus cos alpha. So what sign you will have here? Minus 1 power, this is A13, right? Third element in the first row. So minus 1 power 1 plus 3. Minus 1 power 1 plus 3. Minus 1 power 1 plus 3 is minus 1 power 4. It is plus 1. Okay. So when you consider minus cos alpha, that is A13, last element in the first row, you delete the column having the element minus cos alpha and delete the row having the element minus cos alpha. So we can see a 2 by 2 matrix minus sine alpha 0 cos alpha minus sine beta. So find the determinant of this matrix. Cos alpha into 0, 0. Open the bracket. So multiply cos alpha into 0, it is 0. Then I'm going to multiply minus sine alpha and minus sine beta. I have to multiply minus sine alpha and minus sine beta. First, we have to multiply these two. Then only this will come. So minus sine alpha into minus sine beta is sine alpha sine beta, right? Sine alpha sine beta. When you multiply these two, you will be getting minus sine alpha into minus sine beta. It is sine alpha sine beta. Minus and minus becomes plus. Okay. So then cos alpha into 0. So you will add minus cos alpha into 0 is 0. So downward, then upward. You have to remember like this. When you multiply, when you expand the determinant, you have to remember like this. First, we are coming downward. Okay. So sine alpha, sine beta, downward arrow. Then we have to go upward. We have to move forward. Okay. So you remember this arrow, down arrow, then upwards. So when you go up, you have to add minus sign in the middle. After finishing this, you have to add minus. So first we are coming downwards, then we are going upwards. You have to remember like that when you expand the determinant. So what I am getting is here sine alpha, sine beta minus 0. So simplify. What is minus 1 power 1 plus 2? It is minus. Minus 1 cube is minus. So minus, here I am having this is 0. So minus cos alpha sin beta. So when you multiply this minus and minus becomes plus. So what I'm getting is sin alpha, cos alpha, sin beta. So I have simplified the first term, right? This minus and this is also minus becomes plus. So sin alpha, cos alpha, sin beta. Okay. Next. Minus 1 power 1 plus 3 is plus 1. Minus 1 power 4 is plus 1. Here I am having minus cos alpha. So when you bring this minus cos alpha inside the bracket, what you are getting? C minus cos alpha. This is sin alpha, sin beta. Okay. So sin alpha, sin beta. Sin alpha, sin beta. So if you multiply this cos alpha with 0, then you will be getting 0. So this is the final answer. Sin alpha, sin beta minus cos alpha, sin beta. Sin alpha, sin beta minus sin alpha, sin beta. So it is 0, right? Since both are same, this is 0. So what is the value of the given determinant when you expand this? Determinant, you will be getting 0. So the value of this determinant is 0. This is the answer. Let me check the answer. Yes, the answer is 0. So, are you able to understand? Now see the next problem. Find values of x for which the determinant 3x x1 equal to the determinant 3241. So for what value of x, the left hand side determinant value is equal to the right hand side determinant value. That is the question here. So for what value of x, the left hand side determinant will be equal to the right hand side determinant value. Okay, so this is the condition given here. Okay, we have to find the value of x in such a way that the left hand side value of the determinant is equal to the right hand side value, right? So we have determinant 3x x1 equals the determinant 3241. Expand the determinant given in the left hand side. This 3 into 1 downward arrow minus upward arrow. Okay, so 3 into 1 minus x square in the left hand side. When you expand the determinant, you will be getting this. And in the right hand side, when you expand the determinant, what you will get? 3 into 1. Come downwards, then go upward. Minus 4 into 2, minus 8. So 3 minus x square equal to 3 minus 8. What is 3 minus 8? It is minus 5. So bring that minus 5 to the left hand side. You'll be getting minus 5 becomes plus 5. So 8. And this becomes x square. So x square is 8. Therefore x is plus or minus 2 root 2. This is actually 4 into square root of 4 is 2 and square root of 2 is root 2. So x value is plus or minus 2. So here some x's are given. How will you find the determinant of this matrix? It's a 2 by 2 matrix. We need to expand this determinant, right? So first we have to come downward. Cos theta into cos theta is cos square theta. I'm finding the value of this determinant. Okay, downward arrow minus upward arrow. So I have added minus here, upward arrow, minus sin theta into sin theta, minus sin square theta. Already we have minus here. So it becomes plus sin square theta. So what is the value of sin square theta plus cos square theta? It is 1. So the value of this determinant is 1. Okay. Then see the next problem. A is a 2 by 2 matrix 1, 2, 4, 2. We have to show that determinant 2A is 4 times determinant A. Determinant 2A is 4 times determinant A. So determinant 2A means we have to multiply all the elements of A by 2. Determinant 2A means we need to multiply all the elements of A by 2. Here 2 is a scalar, right? So scalar multiplication is possible. We need to multiply all the entries of A by 2. So first let us multiply that. Let us find 2a. First we find 2a. What is 2a? 2a is also a 2 by 2 matrix. So I'm going to multiply all the elements of a by 2. I'll get 2, 4 in the first row, then 4 into 2, 8, 2 into 2, 4. So this is 2a matrix. This is a 2a matrix. Now find the determinant of 2a. So downward arrow, 4 into 2, 8, minus upward arrow, 8 into 4, 32. What is 8 minus 32? Minus 24. This is minus 24. This is the left hand side, right? This is the left hand side. Now consider the right hand side. What is the right hand side? 4 times determinant A. So first I have to find determinant A, then I need to multiply the value of determinant A into 4. Okay, so first I have to expand determinant A, then I have to multiply it with 4. So what is determinant A? Downward arrow minus upward arrow. So it is 2 minus 8. 2 minus 8. What is 2 minus 8? It is minus 6. Okay, so this is minus 6. Determinant A is minus 6. We have 4 outside. So 4 into minus 6 is minus 24. So LHS is equal to RHS. LHS is equal to RHS. Is that clear? The next problem is a similar type. It's a 3 by 3 matrix. We have to show that determinant 3A is 27 times determinant A. Okay. So it's a 2 by 2 matrix means determinant 2A is it's a 2 by 2 matrix. So 2 square, 4 can be written as 2 square into determinant A. Since the given matrix is a 2 by 2 matrix, so value of 2a, determinant of 2a, determinant value of 2a is equal to 4 times or 2 power 2 times determinant A. Here A is a 3 by 3 matrix. So value of determinant value of 3a, determinant value of 3a is equal to 3 power 3, right? 3 cubed, 3 into 3 into 3 is 27. Okay, so 27 into determinant A. It's one of the property. See the seventh problem. Find the values of x if the left hand side determinant is 2, 4, 5, 1. The right hand side determinant is 2x, 4, 6x. So here we have to find the value of x in such a way that 2, 4, 5, 1 equals 2x, 4, 6x. So first let us find the value of the determinant given in the left hand side. Downward arrow minus upward arrow. So 2 minus 20. Left hand side is 2 minus 20. What is 2 minus 20? It is minus 18. It is minus 18. Okay. Now come to the right hand side. Downward arrow minus upward arrow. So now I am finding the determinant value of the matrix given in the right hand side. It is downward arrow minus upward arrow. So 2x square minus 6 into 4, 24. Okay, so now I have to equate these two because the left hand side value is minus 18, whereas the right hand side value is 2x square minus 24. So I am going to equate these two. I have calculated the left hand side as well as the right hand side. This is left hand side. The right hand side is 2x square minus 24. Right? We can cancel 2. So minus 9 dividing throughout by 2. So minus 9 equals x square minus 12. So now I have divided the entire equation by 2. So you are getting that minus 9 equal to x square minus 12. That is x square minus 12 plus 9 equal to 0. Bring this minus 9 to the right hand side. So x square minus 12 plus 9 equal to 0. The product is 9. Sorry, these two are constants, right? So x square, what is minus 12 plus 9? It is minus 3, right? 9 plus 3 is 12. So x square minus 3 equal to 0 means, which implies x square is 3. So x square equal to 3 means x equal to plus or minus root 3. I will get two values for x. One is plus 3, plus root 3, another one is minus root 3. Let me do this problem, next column. If determinant x2 18x equals determinant 6 to 18 6, then what is the value of x? For what value of x? The left hand side determinant is equal to right hand side determinant. That is the question here. So I am going to expand the determinant given in the left hand side. This downward arrow minus upward arrow. So what you are getting is x square minus 18 into 2, 36. So this is what I'm getting in the left hand side equals. Now come to the right hand side, expand the determinant given in the right hand side. So downward arrow minus upward arrow. 6 into 6, 36, right? So 36 minus 18 into 2, that is also 36. So 36 minus 36, 0. So what I'm getting is x square minus 36 equal to 0, which implies x square is 36. Value of x square equal to 36. So x square equal to 36 means x equal to plus or minus 6. When you square plus 6, you will get 36. When you square minus 6, you will get 36. So x values are plus or minus 6. So the answer is B. Now I move on to properties of determinants. What is property 1? Properties of determinants is very important, because when we do problems, we use these properties. Okay. So what is property 1? The value of the determinant remains unchanged. The value of the determinant remains unchanged if its rows and columns are interchanged. So what does it mean? If you change rows as well as columns, we change any rows or any columns, okay, then the value of the determinant will not be changed. Value of the determinant will not be changed. If I change the first and the last row, first row becomes the last row and the last row becomes first row, means then the value of the determinant will not be changed. It remains the same. Okay, so that is the first property. Here they have verified the property. This is the value of the determinant A1, A2, this is the determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. It's a 3 by 3 matrix. So what is the value of the determinant? This is the value of the determinant. When you consider A1, you'll have B2, C3 minus C2, B3. Then for the next term, you will have minus. So minus A2, B1, C3 minus C1, B3. When you consider A3, you'll be getting plus. So plus A3, B1, C2 minus C1, B2. By interchanging the rows and columns of delta, we get the determinant. Here, the rows and columns are getting interchanged in delta 1. So I'm going to interchange the rows and columns of delta. So I'm going to take it as delta 1. The rows and columns are getting interchanged here. The first row is written as first column A1, A2, A3. The second row in delta is written as second column B1, B2, B3. And the third row in delta is written as third column in delta 1, C1, C2, C3. So now they are evaluating the determinant given in delta 1. Okay, so what will you get? A1 into B2 C3 minus B3 C2. Then when you consider B1, you'll be getting minus. So minus B1 into A2 C3 minus A3 C2. When you consider C1, you'll be getting plus. So plus C1 into A2 B3 minus A3 B2. See that both the values are same. Value of delta, this is determinant value of delta, and this is determinant value of delta 1. Since both are same, I can say that if rows and columns are getting interchanged, the value of the determinant will not be changed. So that is the first property. Actually, this property follows from the property that if A is a square matrix, then determinant A is equal to determinant A transpose, right? So here property 1 is verified in this example. What is delta? Delta is determinant 2 minus 3, 5, 6, 0, 4, 1, 5, minus 7. In this example, they are verifying property 1. So first let us find the determinant value of delta. So delta is equal to, consider the first element in the first row, it is 2. Okay, so when you consider 2, you'll be getting positive sign because A11 is 2. So A11 means you'll be getting minus 1 power 1 plus 1. What is minus 1 power 1 plus 1? It is 2. What is minus 1 square? It is plus. So when you consider 2, you'll be having plus symbol. So plus sign 2. And if you consider A11, then you will see a 2 by 2 matrix 0, 4, 5, minus 7. Find the determinant value of that matrix. Then we have to consider minus 3. That is the next element in the first row. So A12. This is actually A12. A12 is minus 3. Since A12 is minus 3, I will have negative sign here because minus 1 power 1 plus 2. Minus 1 power 1 plus 2. It is minus 1 cube. So minus 1. So when you consider the next element in the first row, you'll be getting minus here. So minus, if you answer the row and the column having the element minus 3, then you will see 6, 4, 1, minus 7. So consider this matrix and find the determinant value of this matrix. Now come to the last element in the first row, it is 5. A13 is 5, right? A13, this is A13. A13 means minus 1 power 1 plus 3. What is minus 1 power 1 plus 3? It is minus 1 power 4. Minus 1 power 4 is again plus. So plus 5. Delete the row and the column having the element 5. So it will be matrix 2 by 2 matrix 6, 0, 1, 5. 6, 0, 1, 5. Now evaluate this. 0 into minus 7, 0. Downward arrow minus upward arrow. So 0 minus 20, minus 42, minus 4, downward arrow 6 into 5, 30, minus 1 into 0, upward arrow, so 0. So simplify this. Here you'll be getting minus 20 into 2, minus 40. This is minus 46. Minus 46 into 3, minus 138. This is 30. 30 into 5, 150. So when you simplify, you are getting minus 28. Okay. So this is determinant value of delta. Now I am going to interchange rows and columns. So the first row is written as first column in delta 1. 2 minus 3, 5. The second row is written as second column, it is 6, 0, 4. And the third row is written as third column, so 1, 5, minus 7. Actually, what we are doing is we are finding the transpose of the given matrix A. Now find the value of this determinant. So 2 into 0, 5, 4, minus 7. Then this is minus 6. Minus 6 into minus 3, minus 7, 5 into 5. Plus 1 into minus 3, 0, 5, 4. 0 into minus 7, 0. Minus 4 into 5, minus 20. Then minus 6. When you write the next element, you will add minus here. So minus 21, minus 20, right? Then plus 1 into minus 3 into 4, minus 12. So what are you getting here? Minus 20 into 2, minus 40. Here 6 into, this is actually downward arrow. Minus, not minus 21, plus 21, right? Minus 3 into minus 7, plus 21. Plus 21 minus 25, right? So this is actually minus 4 plus 24. So 2 into 0 minus 20. 0 minus 20 is minus 20. Then minus 6 into minus 3 into minus 7, 21. Minus 25. Plus 1 into minus 12. So minus 40. This is actually minus 4. 25. Minus 25 plus 21 is minus 4. Minus 4 into minus 6 plus 24. This is minus 12. So what are you getting? Minus 52. Minus 52 plus 24. So 12 minus 4, 8. 4 minus 2, minus 20. So here the property is verified. If we interchange rows and columns, then the value of the determinant will not be changed. It will remain the same. That is the first property. What is the second property? If any two rows or any two columns of a determinant are interchanged, then sign of determinant changes. If any two rows or any two columns of a determinant are interchanged, then sign of determinant changes. That means what? If I interchange the rows, first two rows means, then in the determinant value, the sign will be changed. That is the meaning of this property. If any two rows of a determinant are interchanged, if you interchange any two rows, for example, if I interchange these two rows, okay, that means the first row becomes B1, B2, B3, and the second row becomes A1, A2, A3. So here I have interchanged the first and the second row. Okay, I have written the second row as first row and the first row as second row. So if I interchange any two rows, or you can interchange any two columns, then the value of the determinant will change. Okay, if you get positive sign when you expand the given determinant, then after interchanging you will be getting minus sign. Okay, so that is the meaning of this property. Here they have found the value of determinant value of the given matrix A. It is A1 into B2 C3 minus B3 C2 and A2 A3. So after this, they are interchanging first and third row. So what is the third row now? C1, C2, C3. First row is A1, A2, A3. So now if we expand this, how to expand this? C1 into down arrow minus upward arrow. So B2 A3 minus A2 B3. This is A2. And what is C2? C2 is A12, next element. So minus 1 per 1. Minus C2 into, we'll have B1 A3 minus B3 A1 plus C3 into B1 A2 minus B2 A1, right? So when you simplify, you'll be getting the same value, but the sign will be changed. Okay. Here I am getting C1 B2 A3 minus A2 B3 C1 minus A2 B3 C1. Where is A2 B3 C1? See, here I am getting plus A2 B3 C1, whereas in delta 1, when I am expanding, I am getting minus A2 B3 C1. Minus A2 B3 C1. So like that, you will be getting the sign changes. So that is property number. Property number 2 is verified in this example. I'll stop with this. We will see in the next class.